Hi guys, welcome back to the channel. Today I'm going to be doing a new video for you about Azure and event distribution systems. Okay, basically after this one I'm going to be posting one on AWS as well, which is going to have similar concepts, but this one's going to be focusing on Azure. Okay, so let's kick things off with a fundamental question. What is a distribution system? Okay, think of it this way. Instead of building one colossal application that handles everything, you break it down into smaller independent services. Each service does only one thing really well, and they all work together across multiple machines, so you've got multiple services across a domain, sometimes even across different continents. This approach makes your applications incredibly resilient, scalable, and much easier to maintain than a monolithic application where everything's within one system. Okay. So that's an introduction to an event system, right? The heartbeat of modern apps, event-driven architectures. Now, a concept absolutely central to modern distributed systems is event-driven architecture. This isn't about the direct course between services, it's about reaction. When something significant happens, i.e. an event, a service publishes it, and other services that care about that simply react to it. It's like a sophisticated digital nervous system, allowing incredible flexibility, real-time responses, and fantastic decoupling between your components. Okay, so let's look at Azure's nerve sensor, which is basically event grid and queue storage. So how does Azure enable this event-driven magic? The cornerstone is Azure Event Grid. Imagine a smart serverless switchboard for all your events. Instead of services shouting directly at each other from one service to another, they publish their events through an event grid. An event grid intelligently routes them to whichever services are subscribed to hear about them. It handles events from virtually any Azure service, your custom applications, and even third-party SaaS providers. It's incredibly powerful for building reactive, scalable solutions without managing any infrastructure yourself. And when we talk about reliable asynchronous communication, we can't forget Azure queue storage. This service provides a robust, simple queuing mechanism. Think of it as a holding pen for messages that need to be processed later. Services can drop messages into the queue, and other services can pick them up when they're ready, ensuring that even if a part of your system is temporarily busy or offline, the messages aren't lost. Okay, so now we've moved into messaging. Let's talk about Azure Service Bus, which is advanced messaging. Beyond simple queues, for enterprise-grade messaging and requirements, Azure offers Azure Service Bus. This is where you get more advanced patterns, which supports topics and subscriptions, which are really important. I'll get to them later, allowing you to implement a publish-subscribe model, where one message can be delivered to multiple subscribers. So normally with a queue, you'll have a one-to-one relationship, which is basically one message being published to one sender being published to one receiver. With a topic, you can have one sender being published to multiple receivers. You also get features like message sessions for order processing and dead letter queues for handling messages that can't be processed. So you may have a validation step on the first service on your messages, so they might check like basically content. So if something fails validation, you can put it in what's known as the dead letter queue. So basically this message shouldn't go through the system when it's already failed validation. Service Bus is your go-to for complex workflows, ensuring guaranteed message delivery and sophisticated routing in mission critical applications. Okay, so let's look at like basically how Azure recommends you handle these events. So let's look at short-lived power, which is Azure functions. Yeah, let me give you a practical example. Imagine a user submits a large report for analysis. This submission can trigger an event. Event Grid then forwards that event to an Azure function. The function might kick off a data processing job, for example, running some quick calculations or sanitizing the data. Because Azure functions are serverless, they spin up only when needed. Execute your code and they shut down, meaning you only have to pay for compute time you actually consume. It's perfect for those event-driven bursts of activity. In terms of languages for this, basically my recommendation for this most of the time is to go for Go. They have smaller binaries than .NET, and they've got a better concurrency model. So basically, a little simpler, and a concurrency model, so basically you can run multiple ones at once, a lot easier. Obviously, you can use any language you want for this, but my recommendation for short-lived power Azure functions is using Golang. Okay, so now we want to orchestrate complexity. So there's a concept in Azure, which we haven't got in AWS, called Azure durable functions. Okay. Now, what about workflows that are long running? asynchronous, and need to maintain state across multiple steps. This is where Azure durable functions truly shine. It's a game changer for building stateful serverless applications. So it's still serverless applications, but in essence, they're stateful. You can write complex orchestration logic using regular code, and durable functions handles all the behind-the-scenes state management, retries, and checkpointing. Think about handling a multi-step financial transaction approval, for example, or perhaps an image processing pipeline that needs to wait for multiple steps to complete. Durable functions makes these complex distributed workflows surprisingly straightforward. For durable functions, .NET is the language I'd use. Basically, the SDK for durable functions is really mature and really good. So next we go managing flows. Managing flows with queues. So let's look at another example. So we've got serverless, we've got a stateful serverless, which is in the middle. Now let's look at managing flows with queues. Let's switch our example to see queues in action for managing sequential state. So basically these services have to run in a specific order. Consider this customer support ticket system. When a new ticket is logged, enter the queue. A separate CR service picks it up, analyzes it, and puts it onto another queue for an agent assignment service. Once assigned, it might go to a resolution service queue, and finally a notification service queue to alert the customer. Each service processes parts of the workflow independently, relying on queues to ensure reliable, ordered, which is important, progression of the ticket through its life cycle, even if one service is temporarily busy. Again, my advice for this, you can use any language for this, or you could use Java, .NET, Python, Golang, anything you want, really. Sorry, for the previous one for durable function, you can still use Golang as well. I just recommend using .NET. Again, horses for courses, depends on what type of service it is, on what language you use, really. Okay, so next let's look at your API front door. So basically we've got the three different types of services, if you like. Stateless, stateful stateless, and we've got order processing. So basically these are all surrounded by a domain, and we've got a front door. Okay, so we built all these these fantastic backend services. How do we expose them securely and efficiently to your front-end applications or external partners? That's where Azure API management comes in. It's actually a robust gateway for all your APIs. You can define, publish, secure, and manage your APIs at any scale. It handles critical aspects like authentication with Azure Active Directory, request throttling, caching, and even transforming API calls on the fly. It also provides a developer portal, making it easy for consumers to discover and integrate with your services. It's really, really handy tool to have. Basically, most of the modern event distributed systems on Azure always have API management on there. Okay, so let's look at global resilience. So let's look at Azure Front Door and Traffic Manager. For truly global distributed applications, you need more than just regional deployment. This is where Azure Front Door and Azure Traffic Manager become indispensable. Azure Front Door provides intelligent global routing, ensuring user requests are directed to the fastest, healthiest backend. It also a bit like a load balancer. It also acts as a powerful web application firewall for security and for SSL offloading. Traffic Manager, on the other hand, is excellent for DNS-based traffic distribution across different endpoints, enhancing resilience and performance by routing users to the nearest available service, a bit like a CDN. These services are key to building applications that can withstand regional outages and deliver a consistent experience worldwide. Okay, so next what we need to look at, so we've got our distributed system, we've got our front door, we've got basically a global implementation of these services. So what about seeing inside? What about observability with Azure Monitor? When you're running a complex distributed system, you need to know what's happening inside them. That's where observability comes in. Azure provides an incredibly powerful suite of tools, primarily Azure Monitor, that gives you insight. Azure Monitor collects metrics and logs from all of your services, allowing you to create dashboards, set up alerts, and understand performance bottlenecks. Coupled with application insights, you get end-to-end distributed staging, letting you follow a single request as it hops through all your different services. This is absolutely crucial to quickly identify and fix issues before they impact your users. Okay, so that's your typical Azure distributed system, but there's other core services for distributed systems. Azure's vast and ever-evolving cloud platform. We've only scratched the surface, don't want to go into it in too much detail on one of these talks, but here are a few more essential services for building distributed systems. Obviously, you've got databases, from highly scalable NoSQL options like Cosmos DB to relational powerhouses like Azure SQL and Postgres. Azure is a database for every distributed workload. Storage. So beyond queues, Azure Blob Storage is fantastic for massive amounts of unstructured data, while Azure Files provide shared file storage. So compute, obviously besides functions, Azure Virtual Machines give you full control, and Azure Kubernetes Service is your go-to for container orchestration at scale. Containers are really useful if you've got a legacy application. You don't really want to upgrade it. Basically, containerizing it is one option which a lot of clients have used. And also you've got integration. It's the key tool really. So your logic apps allow for a low-code, no-code workflow automation, easily integrating disparate systems and services. So there you have it, a comprehensive, unique look at building powerful, resilient, distributed systems on Microsoft Azure. Hopefully this has given you plenty to think about and new tools to explore. There's always more to learn from the cloud world, so keep experimenting. Don't forget to like and subscribe for more cloud deep dives, and I'll catch you in the next video. If anybody needs any advice or help with any of this, feel free to message me on LinkedIn or YouTube, and I'll be happy to help where possible. I hope you have a lovely day. Thanks very much for watching this video. Bye bye.